we're going to talk about inequality properties for sides and angles of triangles. Before we get into that, we have to talk about the comparison property. What's there? I don't think there's two R's in there. Remember, when you mock me, you're going to be on tape. Comparison. What's wrong?
I think you were right with the two R's.
I think I was.
No, you're not.
No,
It's only
it's
one
not.
R.
You spelled that.
I don't want to give 22 R's.
Okay, that's right.
One R.
Comparison property. Says if C is equal to A plus B, you might switch their letters around, but it's the same concept. Okay? Then that means then that C is bigger than A and C is bigger than B. And then we'll have some restrictions, same, we're just talking about positive numbers. What's that? Yeah. Sorry. The book has this A is equal to B plus C. Should we switch that, or are you okay with
Yeah,
it? Switch it? Want it to match the book? No?
sure do.
Okay. Well, if you don't want to switch it, don't. C has to be bigger than 0. And A is going to be bigger than B. Okay, so we have a little rule on to make them. So we're talking about negatives because the negatives will mess things up. Okay. All right. What we're getting at, if we're just talking about positive numbers, and we can throw some negatives in here, but we have to be careful with that. But if we just look at like 5 is equal to 3 plus 2, then that means that 5 is what? Bigger than 3, and 5 is bigger than 2, right? And so this property kind of seems like common sense, but sometimes we have to point the obvious out in a geometry class, and that's all we're talking about here. Okay? We have a couple of theorems, actually a few theorems, that we want to talk about. First of all, let's do a corollary to the corollary. Sorry. I don't have my glasses on either. Corollary to the triangle exterior angle theorem. Okay? Remember what that one said?
Isn't it some exterior angles equal 360 degrees?
No.
No, that's not what it says.
That's the polygon exterior angle theorem. The triangle exterior angle theorem says if this is 1, 2, 3, 4, that measure of angle 1 is equal to the sum of the remote interior angles, which is measure of angle 3 plus measure of angle 4. Okay? Question you're probably still seeing on your test. So we need to make sure we understand that. So we've used it before. And now the corollary to this is saying then that since measure angle 1 is equal to measure angle 3 plus measure angle 4, that means that measure of angle 1 is bigger than measure of angle 2, and measure of angle 1 is bigger than measure of angle 4. Did I say 2? I'm sorry. 3. Sorry about that. These are the remote interior angles. And this is the exterior angle, and that exterior angle is equal to the sum of the two remote interior angles, which makes it bigger than either one of them. Okay? So that's a corollary. Remember what a corollary is? It's simply a statement that what? Oh, bless you. Anybody at all remember what corollary is? A statement that follows a theorem. That adds more information about it. Now, we had our theorem for the triangle exterior angle theorem. We had that a long time ago. So this corollary took a while to surface. Okay, but it does go along with that theorem. Any questions on that? So if I have, oops there, that's not what I wanted, right? If I have this, you know what? I'm going to hold off on that because we're going to also apply something we haven't talked about yet. We're about to talk about it. So we'll come back to this one. All right? Let's go to the next theorem. Again, these theorems don't have names to them. The next one says if two sides of the triangle are not congruent, then the larger side lies opposite. Then the larger angle lies opposite the larger side. Two sides of a triangle are not congruent, then the larger angle, bless you, lies opposite the longer side. Okay? So Might not copy that down? Okay, let's go back now. So in this picture, let's say this side here is 20, this side is 17, and this side is 9. Obviously not drawing the scale, right? Okay. 1, 2, 3, 4. We want to know what is the largest angle. What is the largest angle?
I'm a lot big.
Must be angle 9.
That's a 4. He's trying to draw that neater for you.
Thank you.
Looks safe.
Okay? Which angle's the largest? What's your group say back there, Lorenz? 3? Marissa, what's your group say? 1? Obi-Wan, what's your group say? 1? Emma, what's your group say? 1? What's your group say?
2.5.
I asked Kimberly what her group said.
Kim asked to answer, that's not fair.
1?
I don't wanna be in your group.
Alright. Now, if we look at the triangle, if we look at the triangle and apply the rule we just said, the largest side is 20, right? So what lies opposite the largest side? The largest angle, right? So the largest angle is 3. Do you agree? Except the rule we just talked about here says since 1, measure of angle 1 is equal to measure of angle 3 plus measure of angle 4, then that means measure of angle 1 is bigger than measure of angle 3. So in the triangle, the largest angle is 3, but then 1 is bigger than 3. So the biggest angle is angle 1. What's the next biggest angle? Angle 3. What's the next biggest angle?
4.
Well, the next biggest side is 17, so opposite of that is angle 2. And then the next one is angle 4. Okay? All right, any questions on that? All right, very similar to that rule. In fact, we'll put on the same one. We have a theorem that says if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So two angles in a triangle are not congruent, then the longer side lies opposite the larger angle. Okay? Okay, I'm going to pause this. We're going to do a little bit of an experiment here in class, and we'll come back and take some notes on it.
Do we tape them back up?
Yes, please.
Right there, dog.
So the triangle inequality theorem says any two sides of a triangle, kind of putting this in my own words. Any two sides of a triangle must have a sum that's longer than the third side. Any two sides. And so if we have this triangle, we're saying that AB plus BC must be bigger than AC. We're saying that AC plus BC must be bigger than AB. And AB plus AC must be bigger than BC. This is what this theorem is saying. I'm sure they worded it more eloquently than I did, but this is the point of what the theorem is saying. Any two sides added together must be bigger than the third side. And so that's the problem we had with our straws. Occasionally, two of the straws were too short to add up to be more than the length of the third straw. Okay? So today in your homework, you're going to be playing around with these comparisons. They're going to ask you to list sides in order from smallest to biggest or biggest to smaller. They're going to ask you to list angles in order from biggest to smallest or smallest to biggest. They're going to ask you if these three sides make a triangle. Okay? Do these three sides make a triangle? So let's experiment with that a little bit. My sides are 6, 7, and 13. Do they make a triangle? Okay, well, 6 plus 13 is bigger than 7, right? And 7 plus 13 is bigger than 6. But is 6 plus 7 bigger than 13? No, it's not bigger. It's equal. So those three sides will not make a triangle. Okay? That will not make a triangle, so the answer is no. Now, do I have to test all three options?
No, because you already know the one is
No, all I really need to know is what?
one.
Do the two smallest sides add up to be more than the biggest side? That's all that really matters, right? And so all I really had to test was this one here. So if I have 2, 7, and 8, okay, which is the one I have to test?
2 plus 7.
2 plus 7, is that bigger than 8?
Yes.
Yes, it is. 9 is bigger than 8. Okay, so will those three make a triangle? Yeah, so the answer would be yes. Okay? These two add up to 9. 9 is bigger than 8, so we can make a triangle out of that. Okay? Yeah. All right, let me pause this for a second. I think I recorded this. Reminder, here's your assignment.